Last idea we're going to talk about is the idea of crossover temperature. Now, crossover temperature is formally defined as the temperature in which delta G switches from positive to negative. Now, there's only one number that sits between the positive and negative end of the spectrum, and that's zero. So basically, we're looking for the point where delta G equals 0. What you're going to use is your Gibbs relationship. Delta G equals delta H minus T delta S. If delta G equals 0, this means that T is what's called the crossover temperature, or TCO. Now, to solve this, you have to give them both delta H and delta S. Now, these can be found by using Hess's law, so go check on the previous videos, or it's going to be something that you're given. Well, let's say you're given the example delta H equals minus 31.4, and delta S equals 111.1 joules per mole Kelvin, and this is kilojoules per mole. Now, to solve for T, we've got these equal to 0, so we're just going to pull the T delta S over, divide by delta S, and we get T equals delta H over delta S. Now again, keep in mind your units of S. S is typically on the order of joules. So we're going to need to convert this to kilojoules to get minus 31.4 over 0.1111. This gives us a crossover temperature of minus 283 Kelvin. Now, keep in mind, we can't have a real T crossover unless we have a condition that both delta H and delta S are positive, or both delta H and delta S are negative. This means that if you have a situation where one or the other is negative, you're always going to end up with a negative temperature, which is an infeasible temperature. You're always going to have a point where your delta G is positive, or you're always going to have a situation where your delta G is negative. A bit more of analysis, qualitative analysis down the road. But this is basically the only formula you'll ever use for using T crossover temperature, for figuring out the crossover temperature. It's always delta H over delta S. Again, remember to keep your delta S in terms of kilojoules or your delta H in terms of joules, and solve directly for the temperature.